Hello and welcome. You're watching India Fights Back, our special show on India's battle against COVID-19, and I'm Vishal Dahiya. Today we're going to talk about common cold virus and the COVID-19 pandemic. In fact, one of the biggest mysteries of the COVID-19 infection in India relative to other countries like the United States of America and UK has been the lower mortality recorded here. An explanation has now been posited in a study carried out by scientists of National Institute of Immunology and AIIMS, and this has been published in Frontiers in Immunology, a top-rated medical journal. Today we're going to talk about this particular study and this relation as well, try and understand what exactly does the study point to. And for more on this, we're joined by two distinguished panelists. I'll introduce them to you, beginning with Dr. Nimesh Gupta, the lead author of the study, as well as head of the Vaccine Immunology Laboratory in the National Institute of Immunology. And Dr. Anant Mohan is also joining us, professor and head of the Department of Pulmonary Medicine and Sleep Disorders in All India Institute of Medical Sciences, Delhi. Welcome, both of you, gentlemen. Let me begin with you, Dr. Nimesh Gupta. Since you're the lead author of the study, if you could, give us a bit of a summary of what exactly this study is about and what does it say? What does it point out?
Yeah, sure. So, hello everyone. So here in this study, what we tried to look into the overall immune responses to the SARS coronavirus 2 in Indian population. And as we have seen that there is a different trajectory of the pandemic across the globe, we tried to look into the major components of the immunological memory, particularly the CD4 T cells and the antibodies. So what we found in this study, when we of course started the work with the patients, those who have recovered from the COVID-19, and we looked into their responses to this virus. As a control, we tried to look into those individuals' samples, particularly the PBMCs, the peripheral blood mononuclear cells from the individuals prior to the pandemic, just as a control. Surprisingly, we observed that even before the pandemic, without any exposure to the SARS coronavirus 2, we observed almost 70% of the cohort that we were examining showed a very robust T cells against the SARS coronavirus 2. And that was a surprising finding that we saw. And then we looked into more details, and what we found is that those T cells, which were mostly cross-reactive T cells, they were belonging to those domains of the virus which are not involved in the spike-related interactions, kind of, we can say, as a non-spike domains of the virus. And what we further delineated in that study is that these T cells, which comes from probably the exposure to the common cold coronaviruses that are circulating in our country, reacting very strongly to the epitopes of the SARS coronavirus 2 and might be implicated in a protective immune responses at a very early stage of infection.
Okay, so if we have to, sum it up in layman's term, Dr. Nimesh Gupta, then would it be, wise, or would it suffice to say that in India the mortality rate was low because we had, most of us had antibodies to the common cold virus here?
Yeah, so just to take this discussion, that this whole observation was mostly depending on the T cells, right? We saw a huge magnitude of T cells. There were antibodies to one of the protein called nucleoprotein in around 35% of the donors, which were existing before the pandemic. But these T cells definitely, the hypothesis which we have posed is they definitely have some role in this low hospitalization, I will say, the low severity of the disease by controlling the virus infection at a very early stage, right?
Okay, let's also bring in Dr. Anant Mohan here. Dr. Anant Mohan, we would like to seek your views on this study as to how do you look at this way of expressing the relation between common cold virus and the COVID-19 pandemic. Also, if you could corroborate that with the kind of facts you would have seen over a period of this whole year, because you've been directly involved with the treatment of COVID-19 patients as well.
Yeah, I think it's an interesting study because what we have been trying since the beginning is to always we have been trying to compare our patient profile, the severity and the spectrum of our clinical profile of COVID-19 with compared to the other countries across the world. And we have seen some differences. One of them probably is the relatively low mortality that we have been kind of seeing overall. We have been trying to explain why these changes, the differences in severity and clinical profile are happening. No doubt, immune response and immunity plays an important role in the deciding the severity of a disease in an individual also, and when we talk about it as a population as well. So this study looked at that particular aspect. The T cell responses are the T helper cells, and they are the ones that help in boosting up the immunity of the cell mediated immunity. So anybody who has already got a particular level of cell mediated immunity, which was detected by means of these T cells, CD4 cells, that means that probably they have some protection already because of whatever means, because of exposure to some other virus, because of exposure to the virus that causes common cold. These viruses are very prevalent in India, and they are, and we know that common cold and other respiratory infections are very common. So if they are protected to some degree, that means probably that can explain in some way that why the infection with COVID-19 was maybe not so severe as it could have been. So this is something that comes out. This hypothesis comes out, and that is kind of shown in this study. So interesting study, and it would be nice to go deeper into it if possible and find out whether it really is affecting the mortality and the severity. That was a retrospective kind of study which Dr. Gupta has done. Exposure to patients who were before this controls. Now, prospectively, if something can be planned, maybe it would add on to all of these.
Okay, okay. Dr. Nimesh Gupta, a prospective study on this, as Dr. Anand Mohan is suggesting, should be the next step forward.
Yeah, exactly. So there are two options. So one, which Dr. Mohan is suggesting, definitely we looked into those aspects where we can have a prospective cohort study, the individual before and after COVID-19, and what happens to their cross-reactive immunity before the COVID-19, and what happens to that when they acquire the COVID-19, whether they are asymptomatic, whether they are mild, or whether they are severe. So that's one ideal situation which we have been trying, but of course logistics are there which are not allowing us to get into that mode. But we have an alternative, and another alternative that can allow us to address the same question in a vaccine cohort, and we are moving to that.
Okay. One thing which we would like to understand here, Dr. Gupta, is as to why you and your team went ahead on this aspect of the COVID-19 pandemic and looked into it. Is there some other evidence there which suggests that we can go further and explore this particular aspect of the correlation between common cold virus and the COVID-19 pandemic?
Yes, right. So, there are two major aspects. One, the hypothesis which we have posed. So, I'll just tell you in a very, a basic way that when we have a virus infection, it's somewhere get into our upper respiratory tract, goes down to the lungs and replicates in the epithelial cells, right? In the bronchial epithelial cells or in the nasopharynx and all. Now, if we have some T cells which are available before that infection, what will they do? They will immediately control the virus burden by controlling the spread of the virus from cell to cell, because they will kill those cells which are now ready to produce the virus. Now, that way, when we pose this hypothesis, that way what will happen is it will control the severity of the disease. It will control the overall course of the severe disease, but it will not control the spread of the virus. So when we were getting this data initially, that when we saw that unexposed individuals are showing quite a high magnitude of CD4 T cells that are reacting to the SARS coronavirus 2, we immediately posed this hypothesis that this is exactly what we are seeing in India, right? That you have a huge spread of the infection. There's a very high magnitude of the infection, but there is a least hospitalization. There is a very low severity in the disease. It means somewhere these cells which are already available in us are playing a crucial role. So with that hypothesis, we get into the details. And then we tried to understand that because these are, of course, the infection in the same tissues like the upper respiratory tract going down to the lungs. Do we have some kind of, the memory which is helping us here? And that's where we found that, some of the common cold viruses like OC43, okay, it's one of the common cold virus which belongs to the same family of SARS coronavirus 2. It's a beta coronavirus. And it has shown us a very strong antibody responses before and after COVID-19, unlike
Okay.
other coronaviruses that belongs to the alpha coronaviruses family like NL63. And that was surprising for us. So we posed this hypothesis, and then we looked into more details. And I can definitely share with you here that we have pinpointed to two of the common cold coronaviruses that we believe that they might be playing the role here in this cross-reactive protective immunity, which is leading to the less severe disease in our country.
Okay, that's a very interesting point out there, Dr. Anantmohan. Would you a little bit more elaborate on those aspects which Dr. Gupta is pointing out in terms of the hypothesis based on which him and his team went ahead and studied further this particular aspect?
Well, the hypothesis is again simple, to try and see how, because there are so many viruses which cause common cold and cold-like symptoms. Even COVID-19 is predominantly a cold-like upper respiratory disease. And there are so many rhinovirus, influenza virus, there are several adenovirus, many of them. And then within that same virus family, there are many other kind of different strains of that particular virus also that cause. For example, the SARS coronavirus, all of them do not cause COVID. Some of them cause much simpler, just upper respiratory infection, which may be mimicking a common cold. So basically, one wants to see whether exposure to one particular organism confers protection against exposure to another organism. So if somebody has been exposed to one particular, or not one particular, maybe many other viruses causing common cold in the past, whether when they get the SARS coronavirus infection causing COVID, do they have a different pattern of disease? Do they have a more virulent disease, more severe disease, or do they have a less severe disease, or maybe it doesn't matter? And that all the severity of disease in an individual depends on many factors, and one of them is their own immune response. Hence, to look at the immune response of the person at that point of time, and that may help that these antibodies or this immunity is already there existing against a particular virus. So probably that is helping against that other virus as well. Hence, that was the surmise on which this was being looked at.
Okay, but Dr. Anantmohan, does this, the findings of the study have any bearing or should have any bearing on the strategy which we have adopted against the COVID-19 pandemic? Obviously, every day we're learning more about the virus, its working, as well as the way we can tackle it. But based on these, this information, this set of information now, is it of a larger use to us in the long-term strategy?
Well, that is what one will have to now try and do. That is what now in the laboratory they have worked out a kind of a strategy. They have come to some interim conclusions. Now we'll have to see whether this can be put into clinical practice. One thing which we can do is, for example, if patients come to us when we take the initial history, we can lay a little bit more stress on the previous history of common cold and common cold-like infections that the person may have had in the recent past at least. So that is one thing that probably we can stress on. If he has history of multiple infections, multiple sore throats, common cold-like symptoms, or influenza, flu-like symptoms in the past, then one can think that okay, maybe he has some degree of immunity against that particular virus. And then, of course, we cannot confirm this, but we will have to follow up this patient and then see how he behaves, how the COVID behaves in that patient. And then that is what we were talking about, the prospective part of the study. So along with the study part, research and clinical work can go side by side. So that probably may be a help at this point of time. And then maybe as we learn more and more, we can look at it from further angles.
Okay. One more very interesting aspect here I'd like to bring in here, since we're talking about the correlation between the common cold virus and the SARS-CoV-2 as well, the virus which causes COVID-19. Dr. Nimesh Gupta, another study is there in journal Science which says that in future, novel coronavirus may resemble, the mild cold causing coronavirus. So if you're looking at that aspect, the question here is, one, do you agree that this might be the future pattern here? And if that happens, then how do we look at the future scenario here?
Right. That's a very interesting assumption, I will say. That study is mostly on the mathematical modeling, considering the previous history of the other common cold coronaviruses. So we have to be very careful here with a caution that the assumption is that if the SARS coronavirus 2 becomes endemic, and second, it becomes primarily the infection for pediatric population. Okay, so if we assume that this is going to happen, then it may follow the similar path like what we speculate in our field about the other common cold coronavirus called as OC43, which is now related to the that 1890s Russian flu, which has killed almost 1 million of the population, and that was again coming from the animals to the human population. So there is a possibility that this virus will become endemic if we have the huge population, particularly the senior population, becomes immune to it, and then it becomes just left like a disease for the pediatric population, those who do not develop the severe symptoms but do develop the protective immunity, which actually lasts for a long time in terms of the cellular immunity, and then provide the protection in adulthood or in the later stages of the life. So it's quite possible. Yeah.
Okay. Dr. Anant Mohan, your views there on this aspect and that study which is there in Journal Science, because this becomes really interesting to understand how this, the SARS-CoV-2 might evolve in future.
Yeah, correct. So this assumption always will be there because going by the previous viruses and the epidemics, it is quite possible it's already become a pandemic. Now, when it's kind of settles down to, so as to say, and suppose what we call as the so-called herd immunity is developed in a way, if it does, and it becomes endemic, it is also possible that viruses, it will keep on mutating. And if it keeps mutating, there may be a time when a particular type of virus settles down and gives rise to repeated episodes of common cold, just like many other viruses are doing, or some other sore throat type of infection, upper respiratory infection that other viruses are doing, and it will become one of the other viruses which cause upper respiratory infection. That is one. The other thing that may happen is because it keeps mutating and we don't know what is the frequency of mutations, and some of them are harmful, some of them are not. The vaccine which is being developed, we'll have to see whether the vaccine will, how long protection it will give, that is one, and whether we need to repeat that vaccine again annually or again and again like it is being done for the influenza vaccine. So the influenza vaccine, every year a new vaccine has to be developed depending upon the strain which is prevalent at that point of time, depending on the northern or the southern hemisphere. So whether that same strategy will have to be adopted for this also in future. So all these are decisions which we don't yet know, but they will have large implications on public health policy and also on therapeutics in the future, because vaccines will have to be made accordingly, if at all it is required to be made in that fashion. So yes, there may be a stage where we see at least one or some strain of this coronavirus to be settling as an endemic kind of a organism and causing recurrent maybe outbreaks or just a simple kind of a upper respiratory infection in the general population as other viruses are doing.
Okay, that's quite an interesting assumption out there, and as you're pointing out, Dr. Anant Mohan, it will be really interesting to see as to how things proceed there on that aspect. Dr. Nimesh Gupta, one last question I'd like to ask you is, and then coming back to your study and your paper out there on the correlation with the common cold virus as well as with the lower number of fatalities in India in COVID-19. Now, to what extent do you believe, or your study points out in terms of this common cold virus aspect might be responsible for the lower number of case fatalities in India, COVID-19 case fatalities?
Yeah. So it's very likely, our study, what we have done is on a very specific immunity. It's kind of adaptive immunity that we have worked on, the cellular immunity, which is specific. And here we show that there is a very close homology between some of those epitopes of the common cold virus and the SARS-CoV-2, and that's why these T cells are responding robustly to the SARS-CoV-2. So in my opinion and in my hypothesis, which we are working on right now, is yes, if we have the existing CD4 T cells, those who are responding robustly to the SARS coronavirus 2 epitopes, will definitely have some protective implication as well as in the lower rate of the severity in the disease. So it's quite likely as we are coming out with this observation.
Okay. Dr. Anant Mohan, quickly, to sum it up to the last question here, not only this particular study, but it's sort of a general question which I have in terms of since you've been with us on our show quite a number of times for almost a year now, with every new thing which we learn. How do you think we're progressing in scientific terms here in understanding the SARS-CoV-2 and using that knowledge to tackle this pandemic, and this being the latest case here?
I think there has been quite substantial progress, I would say. Of course, it's not complete. There are many more things, right from the starting, talking about the etiology, identification of the type of the virus. That is one, starting off to find out the kind of the genotyping or the genoming of that virus. So one is the structure of that virus that has been found out. Then the second part would be the function of that virus, how it acts. One knows how it acts. One knows the functions to some extent of the spike proteins and how it attacks these cells. And then what happens within the cells and the kind of how it destroys the cellular mechanisms. And then of course to a patient, like in this study, how do patients react? So we know a lot about the symptomatology of the disease now. We know about the symptoms. We know about many rare symptoms also. There have been a number of publications of even the very, very rare symptoms. We know quite a bit about the behavior of the disease, mild, moderate, severe, who are the people who go into severe. We know some factors, some comorbidities which are associated with higher risk of the disease. We know the at-risk population. So a lot of things gradually over a period of time we have got to know, and then comes the therapeutics and diagnostics. So we have diagnostics. We have come a long way. We have now found out how to the PCR is there now. It is becoming more and more robust. It is being done in more and more laboratories. The CBNAT test is being done, the rapid antigen test. So we know a lot about the diagnostics, and then the therapeutics. Among the therapeutics, hundreds of trials have been done on new drugs, on repurposed drugs. Unfortunately, most of them have not really shown us success, but at least they have been done and published, so we know one way or the other. And then finally now about the vaccines. So a lot of information has come, and we have been able to develop so many vaccines which are being implemented. I would say over a 1 year's time, a lot of information has come, starting from the host, the organism, and to the therapeutics and diagnostics. But still, a lot needs to be done, no doubt, because mutations are happening. So now once mutations start, then sometimes it feels we are back to square one and we have to start all over again. So it's a work in progress, but we have made quite a bit of progress.
Okay, indeed, it is a work in progress, but we've done a lot in terms of understanding the virus, its behavior, as well as various aspects, to tackle the COVID-19 pandemic. Thank you so much, Dr. Anant Mohan, as well as Dr. Nimesh Gupta, for sharing your views and insights on this aspect of the COVID-19 pandemic, that is the relation between common cold virus and the case fatalities in India of COVID-19. Now, we'll come back again with a different topic, but before we leave, let us also remind you once again about the COVID-19 appropriate behavior, the best defense against the COVID-19 pandemic. 3-step simple process. First is wear your mask at all times when you step out of your houses. Also, please ensure that you wash your hands regularly. Hand hygiene is really, really important. And so is physical distancing, following physical distancing of at least 6 feet when you step out in public places. These 3 simple steps will go a long way in keeping you and your near and dear ones safe and secure, and everyone else as well. Keep watching Sunset Television. Thank you.